Hello. Today we are going to learn how to substitute numbers in a formula and possibly to change the subject of the formula if needed. Let's have a look at this example. It says the area of a ring with outer radius A. So this is the ring. So it's this one, this bit. If I draw some lines like that, so this is the ring that the question is talking about. So don't look at the circle in the middle. It's just this bit here. So this area, all of this, the area A, capital of a ring, and outer radius is R, capital R, and the inner radius is lowercase r, is given by this formula here. A equals pi in brackets, capital R to the power of 2 minus lowercase r to the power of 2. Now, in the beginning, it says find area A when R equals 12, big R equals 12, and little r is 6, both in centimeters. So we need to find the area, then we need the formula of the area, which is A, it is given by the problem, equals pi, capital R to the power of 2 minus lowercase r to the power of 2. So we have pi, we have big R and the little r, and now it's time to substitute. And after we substitute, we have to be careful with the BODMAS. We need to follow the order of the operation. So it's going to be 12 to the power of 2 minus 6 to the power of 2 equals, so A equals pi is 3.14, and then 100, so 12 to the power of 2, it is 144, 6 to the power of 2 is 36. So take away 36. So A equals 3.14 times the answer of the bracket is 108. And so multiplying them together, now the area is going to be 3.14 times 108. The answer is going to be 339.12, and the measuring unit it's going to be centimeters squared. We have to pay attention to the measuring units as well, because it could be millimeters, it could be meters, so it depends. And then let's have a look at the second part of the problem, which says find R, the big R, if A equals 37.7 and R equals 2. Now this part B, is not attached to part A, okay? It's different. So we need to rewrite the formula. A equals pi R to the power of 2 minus R to the power of 2. So what do we know in part B? We know the A, so let's put a little dot or a little line under A, and we know the R. So we need to find the R to the power of 2. So what do we need to do? First, we rearrange the formula. So we need to get the R out of the bracket and by itself on one side of the equation. So first thing, to get the R to the power of 2, in this case, out of the bracket, we have to expand. And so we're going to have A equals pi R to the power of 2 minus pi little r to the power of 2. So because we need big R on one side of the equation, and because the sign is plus, actually I'd like to keep R to the power of 2 on the right-hand side of the equation and get rid of this term, minus pi R to the power of 2, all of this. How do I get rid of minus pi R to the power of 2? By applying the opposite operation to both sides of the equation. So we're going to have plus pi R to the power of 2 plus pi R, little r, small r, to the power of 2. You see, we got rid of this one now. And so this is what you see in the next step of this formula. Big A, so the area plus pi r to the power of 2 equals pi, now big R to the power of 2. Now we need just the r, so we have to get rid of the pi. And how do we do that? By dividing by pi, because pi r to the power of 2 is the same as pi multiplied by r to the power of 2. And so we need to apply the opposite operation, which is divided by pi. So divided by pi on this side and divided by pi on the other side. And so this is what we have. A plus pi r to the power of 2 divided by pi equals big R to the power of 2. Now, at this stage, I can see just, we don't have any other, let's say, variables on the right-hand side, it's just R. But R is not just R, it's R to the power of 2. So we have to get rid of the power of the square, so it's R squared. And then how do you get rid of a square? Is by applying the opposite operation, which is square root. So we have to square root both sides. Square root both sides. And so this side, it is going to be, I can swap sides. Now if I want, R equals square root of A plus so A here, this is A plus pi little r to the power of 2 divided by pi, just like that. Now let's have a look at what we have in part B. We have little r, and then pi's, of course. So all we need to do is substitute. So after we substitute, okay, this is what we have. So A is 37.7, so 37.7, okay, plus 3.14 times r to the power of 2, so times 4. I'm going to put 4 straight away, all right? Over pi, over 3.14. 3.14. Square root of all of this. Now, obviously, before we do the square root, we have to do the operations inside the square root. So multiplication first, and then addition, and then division by 3.14. And so the answer to, let's say, we have 3.14 times 4.14 times 4, so it's going to 12.5656 plus 37.7. So the answer of the numerator is going to be 50.26, and this divided by 3.14. Okay, so it's going to be divided by 3.14, and then it is actually 16.006. So I'm rounded to the nearest the 3 significant number. It is going to be square root of 16. And there you go. R square root of 16. Square root of 16 is 4. So final answer is going to be 4 centimeter. 4 centimeter, of course, centimeter is a measuring unit as well. And it makes sense if we look back at the problem. Now, again, if we have a question, which is just a question, it's not a problem solving, and you end up with r square root of 16, with something, square root of something, then the answers will be 2 answers, so plus minus 4. But in this case, we're just going to take the positive value because the minus 4 doesn't make sense. It's a problem solving, and we have to put the answers into context as well. So thank you very much for watching Mathssteps. You can watch the video back to make sure every substitution makes sense so that you can do similar things independently with your teacher. Have a lovely day. Bye-bye.